Let's take a look at combining functions. Here you can see two functions. f of x is equal to 3 multiplied by x plus 1. For convenience, we will label this as function 1. And g of x is equal to x squared plus 2. This is function number 2. First example of combining functions, we will consider function f plus function g. It can be written as f plus g of x, which means the same as f of x plus g of x as displayed. So, we can substitute in the actual functions. That is, we can replace f of x with 3x plus 1, which is function 1, and replace g of x with x squared plus 2, our second function. Now we can perform the add operation. This results in x squared plus 3x plus 3. Combining functions. Second example, we will look at takeaway, or subtracting one function from another function. F takeaway g of x. This can be written as f of x takeaway g of x. We can substitute for the functions. This now gives us 3x plus 1 minus x squared minus 2, which in turn results in minus x squared plus 3x minus 1. Combining functions. The third example is multiplying two functions. f g of x. This can be written as f of x multiplied by g of x. We can substitute in the functions. That is, bracket open 3x plus 1 bracket closed multiplied by bracket open x squared plus 2 bracket closed. To perform this multiply operation, we multiply the terms from the first set of brackets with the terms of the second set of brackets. Let's do this. 3x multiplied by x squared plus 3x multiplied by 2. 1 multiplied by x squared is x squared, and 1 multiplied by 2 is 2. This can be simplified further to give us 3x cubed plus x squared plus 6x plus 2. Combining functions. The fourth example is dividing two functions. F divided by g of x. This can also be written as f of x divided by g of x as displayed. We can now substitute in for actual functions. We get 3x plus 1 as the numerator, all of which is divided by the denominator. In this case, this is x squared plus 2. There is a condition that can be imposed. G of x cannot be 0, as dividing by 0 is undefined.